All right, so we got a L'Hopital's rule problem, it looks like here. Well, wait, let's not be so sure. I mean, okay, the question is from the L'Hopital's rule section, but sometimes they try to trick us. And so before you ever use L'Hopital's rule, you need to make sure that it's okay to use L'Hopital's rule. And actually, I think this is a good example of that. Because let's see, so anyway, we got this limit, you know, we're trying to find the limit as x goes to 0 from the right of this function right here. So yeah, let's go ahead and write it down here. So I want the limit as x goes to 0 from the right of, oh my gosh, it's kind of complicated. 9 over x squared plus 9 divided by 8 over x to the third minus 9. Oh yeah, actually, what was I saying? I was saying, I take back everything I said. I don't know, sorry, I guess I'm just getting warmed up today. So I guess, no, I don't take back anything I said. I'm just really confused right now. So, all right, so here's what you should always do first. Before you do anything, the first thing you should do is try plugging in the number. So always try, whenever you're gonna evaluate a limit, always try direct substitution first. And so, okay, so if we put 0 in for x, well, this is gonna end up giving me, I'm gonna end up dividing by 0 right here, and I'm gonna end up dividing by 0 here. And actually, if you think about what that means, what's gonna happen is as x gets close to 0, this fraction is gonna head off towards positive infinity. And same thing with this fraction. That's gonna head off to positive infinity. Because, and I hope it makes sense why, the reason is that the denominator is getting close to 0. If x gets close to 0, then the denominator is getting close to 0. And if the denominator is getting close to 0, that means your fraction is going to get really big, because when the smaller the denominator gets, the bigger the fraction is going to get. So anyway, so the point is, what we got here is this is an indeterminate form. Since the top is going to infinity and the bottom is going to infinity, this is, of the entire fraction. This is what we call an infinity over infinity indeterminate form. So that means that we can use L'Hopital's rule on this. But before I do that, I feel like I want to simplify it a little bit, because it's kind of a mess right now. So let's try, because let's think about why am I simplifying it first? Because let's think about what L'Hopital's rule would say. What would be the next step? If I was going to use L'Hopital's rule, then I would have to find, well, actually, maybe it's not that bad. Maybe I should just use L'Hopital's rule. I would have to find the derivative of the top, and I would have to find the derivative of the bottom. And right now, I don't want to find the derivative of the top because it looks too complicated. And I don't want to find the derivative of the bottom because it looks too complicated. So I will do a little bit of simplification here, but just a little. So, all right, so I'll rewrite this as the limit as x goes to 0 from the right of, okay, so instead of, what do I mean to say? Derivatives don't like division. So whenever I can avoid division, I think that's a good idea. And so I'm going to rewrite instead of 9 over x squared, I'll write 9x to the negative 2 power. And same deal here. Instead of 8x cubed, instead of 8 divided by x cubed, I can write 8 times x to the negative 3. And now it'll be much easier to use L'Hopital's rule. Okay, so what I want to point out so far is I haven't really done anything. All I've done is I've recognized that it's safe to use L'Hopital's rule because we have infinity. Whenever you have a limit that's infinity over infinity, you can use L'Hopital's rule. And then I just did a little bit of algebra to make this easier to find derivatives. Okay, so now I'm actually going to do something. Okay, so now what I'm going to do is now I'm going to use L'Hopital's rule. So this step is going to be using L'Hopital's rule. And so what L'Hopital's rule is actually kind of it's sort of kind of an easy thing, or at least the idea is easy. You just literally find the derivative of the top. So the limit stays there. And then, okay, I just literally find the derivative of the top. And the derivative of the top is negative 18x to the negative 3. And then you just literally find the derivative of the denominator. So you get negative 24x to the negative 4. And L'Hopital's rule, it's sort of magical that this shouldn't work, or in some sense, you shouldn't take this for granted. That this is something that shouldn't work, but it turns out it does. Mathematicians proved that actually this does work. So it's okay to do this, and then yeah, and so now we can simplify this, and if we're lucky, we can compute the limit. So let's see. So if I simplify this, I get the limit as x goes to 0 from the right of, okay, let's see, negative 18 divided by negative 24 makes, don't tell me, 6 goes into that 3 times, and it goes into that 4 times. So 3/4. So it's going to be 3/4. And then when you have x to the negative 3rd divided by x to the negative 4, that's the same as just x to the 1, because you subtract exponents, and negative 3 minus a minus 4 makes positive 1. And now it's safe to plug in 0, and you just get 0. And that is the answer. So all that work, and we wound up with 0. Which actually kind of makes sense if you think about it, but we'll think about it in just a second. So let's see, give some final thoughts on this one then. So, all right, so when it comes to these straightforward L'Hopital rule problems, the steps are, first, make sure that you have an indeterminate form. So make sure that you have either 0 over 0 or infinity over infinity. That's your first step. And then once you've verified that you have an indeterminate form, then just find the derivative of the top divided by the derivative of the bottom. And it might be useful to simplify before you find derivatives, because that'll make your life easier. And then if you have a limit you can evaluate, then you evaluate the limit and you're done. So I was going to say one other thing before I stop this problem, and that was, notice let's think about the answer of 0. And because once I know the answer, I like to sort of be a Monday morning quarterback and go back to the original problem and see how I might have predicted that would be the answer. So I might have predicted that 0 was going to be the answer, because both of these, both the numerator and the denominator are going to infinity. But X to the third power is a bigger exponent than the second power. And so that means that as X gets close to 0, this denominator is going to 0 faster than this denominator. And so if this denominator is going to 0 faster, then that means this fraction is going to be going to infinity faster. And so basically, in some sense, what's happening is the denominator is going to infinity faster than the numerator. So the way I think about it is the denominator is going to dominate the numerator. And whenever you have a fraction where the numerator gets dominated by the denominator, that's going to mean you're getting close to 0, because big denominators mean fractions close to 0. So that's how you might have actually predicted the answer of 0, and why the answer of 0 kind of makes sense. But if you didn't understand, if what I just said didn't make sense, go home and think about it a little bit more. And if it still doesn't make sense, well, it's not the end of the world. If you can do these steps, that's really kind of the important thing. All right.